This is a pre-lab video on the lab for where is lactose digested. This is a lab that demonstrates the specificity of substrate and the optimal reaction conditions for the enzyme lactase. In class, when we talked about enzymes, we were using the example of hexokinase, which catalyzes the reaction that's shown in front of you now. Let me remind you what we talked about. This reaction, as shown, does not happen very quickly. It would take 10,000 years for this reaction to happen because the activation energy is too great. So the reaction is extremely slow. This reaction has to happen thousands of times per second in each one of your cells. And so it needs a catalyst. The catalyst that's used for this particular reaction is hexokinase. When you have an enzyme, it changes the reaction steps. So instead of simply going from reactants to products, we go from enzyme and substrate to a new intermediate, the enzyme-substrate complex. And then the enzyme-substrate complex is converted into enzyme plus products. This introduces an extra step, but in each step now, there's a very low activation energy barrier. So each one of the steps is much faster than the one step of the uncatalyzed reaction. This reaction would take 10,000 years if it was not catalyzed. Yet in our cells, it happens thousands of times per second. Hexokinase was the example that we saw in class. Now we will look at another example, the lactase enzyme. In the digestion of lactose, we need the enzyme lactase. Lactose reacts with water in a hydrolysis reaction. But once again, this reaction is very slow, and it would take many years for this reaction to happen unless there is a catalyst. The enzyme that catalyzes this reaction is lactase. And the products would be the two monosaccharides, galactose and glucose. We will be performing this reaction in lab using lactase in the form of Lactaid pills. These are over-the-counter digestive supplements that help people that are lactose intolerant to digest lactose. We will monitor the progress of this reaction by monitoring the concentration of glucose using glucose test strips. You will dip the test strip into your solution at different time points and measure the concentration of glucose. You should expect that as this reaction proceeds, you should start out from 0 concentration of glucose when you start, and you should increase in concentration as glucose is produced during this reaction. We know that enzymes are pretty specific for their substrates, and in this case, lactose and water are the substrates. But we're not going to just assume this, we're going to test it. We're going to test this with lactose, maltose, and sucrose. We will try digesting each of these sugars and monitoring the amount of glucose in the solution. Notice that glucose is a monosaccharide that's part of the disaccharides in each of these. And so we should be able to monitor reaction progress by monitoring the concentration of glucose at several time points. You will be able to see if lactase is in fact specific for lactose, or if it will also help to catalyze the hydrolysis of maltose or sucrose. After we test the specificity of lactase, we're going to test its optimal operating conditions. We're going to focus on pH. All of our reactions will be run at 37 degrees Celsius, which is the optimal temperature for most of the enzymes in our bodies. We're going to test the optimal pH and determine what the optimal pH of lactase is. And its optimal pH will depend on where it naturally occurs or where it naturally acts. There are 4 zones that we're going to consider. The mouth has a pH of around 6 or 7, which is close to neutral but slightly acidic. If lactase is excreted in the salivary glands and operates in the mouth, we would expect that lactase would have an optimal pH around 6 or 7. Some enzymes are excreted and operate in the stomach. The stomach has a pH of about 1. It's extremely acidic. If lactase is excreted and it digests sugars in the stomach, we would expect that lactase would have an optimal pH close to pH 1. The duodenum is also close to neutral. The duodenum is the first few inches of the small intestine. If lactase's optimal pH is around 7, it may also operate in the duodenum. And the intestines usually have a pH around 8. So if lactase has an optimal pH around 8, which is basic, then we would expect that lactase actually digests sugars in the intestine. Using the optimal pH of lactase, we will be able to determine in which areas of the body lactase might be excreted and digest sugars. Thanks for watching this pre-lab video about lactase and where is lactose digested. If this video is helpful, please let me know by giving me a thumbs up.